So good afternoon. Can you hear me? Good afternoon. So we had two earlier sessions, and in printing we have to understand one thing. Everything ultimately affects the color. So color management, as it is known in the industry and by many suppliers and other people, they look at a very narrow region of the color. They look at the color instrument, setting up on the monitor and calculating and making some profile. But there is much more to color management than just that. Yeah, unfortunately there is a lot of many of these factors are not really understood, and that's why we are still fighting for the color reproduction the way we were fighting 50 years before. The same things, create misunderstanding between supplier, customer and everybody. Color management, we have to take in the anything you put on the paper, basically it is a color. See, what is color? We talked in the earlier session. It's a relation between the light and reflection or transmission of light from a printed surface or anything you see around. So when light comes in, every printed piece, we look at it with the reflector or transmitted light. So the light enters in our eye and it creates the impression. So even if the single color printing, you can also say it needs a color management. Color management is not just CMYK and you make some profile. It has a much more context when it comes to putting ink, even the coating. Yeah. So let's look at how inks and other chemicals what we use in the printing department, how it affects the color. Okay. So we are going to talk about the inks, printing inks. When we get I think it's difficult this because I have a habit of moving around. When we reproduce something, we get various types of originals. We get artist drawing, we get photographs. Photograph can be digital or it can be hard copy, or even the simple black and white matter which we have to deposit on the paper, black ink on the paper. It also needs some kind of discipline, some kind of standardization, some kind of systematic approach. So whatever we get from various sources, in printing we use 4 inks, sometimes just 2, sometimes just single ink, sometimes more than 4 color, and we try to create all that impression within those given inks. So this is what we had seen last time earlier, that there are various aspects of color, what we see in the nature and what we can reproduce. There is a big gap, big lacuna. So we need to apply what we call as a color management. And the color management, I am talking in a much wider sense, not just creating profile and applying. So when it comes to the inks, the basic color is coming from the ink. Even if you take black ink, it is going to produce impression of black in your eye because the light is absorbed by the black, reflected by the white paper, so that contrast gives us the impression. Okay, so light ultimately is related to the color. Then there are different kinds of inks for different printing processes. We have paste inks, we have liquid inks, we have solid inks, and we have powdered inks. People may call it toner. Okay. So the paste inks we are using in litho offset, in flexography when it comes to UV printing. Okay, UV inks are normally paste inks. Letterpress, don't think the letterpress is dead. Unfortunately, that's a wrong impression that is created all over the industry. Letterpress exists in its modern form today. SL Propack, most of their collapsible tubes are printed by letterpress. So you have to look at the development in letterpress and not think about the old metal type. Okay, so letterpress is still very much in existence. In fact, SL they produces 1/3 of the world's collapsible tubes. Yeah, they have plants in different countries. Gravure there are only one or two machines which uses UV ink to deposit. That's why I have also listed gravure under pastings. Intaglio is a process which is like gravure, but it's a process without individual cells. It just image at the lower level, and this is widely used for currency note printing and some special applications, or even there are some special applications when it comes to other type of security printing. Screen printing and pad printing. Pad printing is which uses the intaglio plate, and it's a process where polyurethane ball picks up the ink from the plate and deposits. Okay, so these are pastings. Under liquid ink we have flexography. It uses uses solvent based or water based inks. We have gravure, solvent or water based inks. We have inkjet. In inkjet there are different types of inkjet processes. That's why it's also mentioned under solid. There is a solid inkjet, there is a liquid inkjet, which is a continuous stream of ink that comes out. Electrophotography. In electrophotography, if you think of HP Indigo, they use a liquid toner, so that's why it's again under liquid. And also it's under powder toner, because many electrographic machines coming from other companies, they use a powder toner. Okay, and inkjet is also solid. Yeah, it goes from solid directly to through a vapor stage and deposits it on the paper. So the flow properties required by a particular ink, it decides how much ink you are going to deposit on the paper. So means again ultimately it results in the visual impression, so that color. So what are the components? Each of these components matter to give you the right shade of color on the substrate. Okay, so there are components. One of the components is called colorant, which gives color to the ink or to the toner. There are two types of colorants. One is dyes and the second one is pigment. Dyes are completely soluble in the liquid, in the solvent. Okay, like if you see the photographic print, they use dyes. It's completely soluble in the given liquid. And the pigment is not completely soluble. It is always in the fine, it has fine particles. It's never completely soluble. So that's the difference between dyes and pigments. Dyes give you much wider gamut as compared to the pigments. Pigments, color gamut covered by the pigment is less than the dyes, but the life expected from the pigment is much longer as compared to the dyes. Dyes are fugitive, that means they fade soon as compared to the pigments. So these colorants need some kind of vehicle to carry to the substrate. Okay, so there are resins, so there are natural resins, there are artificial resins, synthetic resins like acrylics and so on. Okay, so the ratio of this vehicle and the colorant that is mixed, it decides what kind of color strength you are going to get when you print. Okay, it's easy to ask supplier to supply cheap inks, and then supplier will reduce the colorant component of the ink and make it cheaper, but then you lose the color strength goes down. Okay, so that's so the color management starts right from here. What proportion are you have in the composition between colorant and the vehicle? Then we add some additives which also has certain effect on the color, because every chemical that you have has certain color it gives to the ink or it gives to the toner. So there are different additives which are required in the ink, and there are old days, if you look at this ink can, you always had some skin formation on the ink. So you have to remove the skin, otherwise you get hickeys when you print. and then you have to take out the ink and print. Today most of the ink manufacturers, they are using these special additives which prevent the skin formation in the ink can, and your hickey problem goes down. Okay, then there are other information, coalescing agents, that is coalescing, that's putting all other ingredients together. Yeah, coalescing agents. Then there are wetting agents, because the surface tension has to be right to deposit ink on the paper. If the surface tension is very high, your substrate will not accept the ink easily. Okay, ink will stick to it, all ingredients within the ink. It will have cohesive forces, it will not have adhesive forces, so it will not go on the substrate easily. Then the transfer is not easy, so again it affects your color. Yeah. Then you have biocides, and then you have secatives and so on. So all these additives has certain property, because each chemical has certain color. Okay. Then you have the carrier, which work as a diluent, which work as a carrier again, and then you have solvent for the liquid inks, Gravure, Flexo. You have carrier liquid for the toner. Okay, if you are using HP Indigo, there is a carrier liquid. Okay, and so there are other ingredients which are added so that your ink becomes easily printable product onto the substrate where you want to print. So each process, each substrate will need different composition, and as a printer, ink manufacturers check, but as a printer you should also check batch to batch whether your ink is carrying the same color or not, and whether it has other properties which are required to deposit ink on paper, whether those properties are there or not. If the surface tension is too high, your transfer will be less, so your color on the paper will be less. And if it happens between the two different colors, if you are putting them together, then your color is going to shift. Okay, so each component has certain tasks to carry out. Okay, so the colorant gives color and also controls the intensity of light. If proportion of colorant is more, the light absorb of some, see, the colorant gives us a light because it absorbs certain part of the spectrum and gives out certain part of the spectrum. So if that colorant proportion changes, the light absorption of unwanted wavelength is going to change and is going to affect your color. Okay, so color intensity will affect. Vehicle. Okay, anchoring of colorant on the substrate. Ink drying. How is your ink drying? If it doesn't dry, then your ink will come off, it will rub off. So to that extent your ink on the substrate is reduced. Colorant into printable form. Okay, dissolve. So has anybody visited ink manufacturing? Ink manufacturing you have visited? Anybody else? Yeah. If you see this ink manufacturing, I mean, it's from certain acids and certain reaction, it gets certain color. For example, if you go to hoovering plant and when they make certain magenta color, the mixture has to have below 5 degrees centigrade. Then it takes that particular magenta color. If it's 6 or 7, your magenta ink changes. Okay, so that's also a big science. Ink technology is again a big science. Then additives. Additives influence ink behavior. Okay, ink drying, ink flow, ink gloss, abrasion resistance, and so on. Then carrier. Okay, transport of colorant. So dyes, which are colorants. Dyes, these are molecules surrounded by solvent, which is a base liquid. Okay, so in Flexo and Gravure sometimes we use dye basings. Okay, in textile they use dye basings. in offset printing we have pigment wastings. Okay, so every molecule absorbs light has a photon. Take the collar mic as well. Yeah, okay, in the meantime I'll continue with this. Okay, I mean once it comes here we can enter for 5 minutes. Okay. Yeah, there is one more. Anybody wants to ask some question, you ask when the slide is in the front. It's always better that way. Yeah, don't keep it at the end, so that when we are on a particular topic it's easier. Okay, so light has a photon which oscillates, okay, creates a wavelength and gives you a particular color of light. So every molecule absorbs photon, so certain portion of the light will be given out, certain will be absorbed. Then higher the color intensity, the more luminous the color, that is brighter the color. Okay. Dyes, as I said, has a larger color gamut compared to pigments, because in pigment there is a lot of light scattering because of the particle size. In dyes there is no light scatter. Yeah. So dyes are transparent, molecules significantly smaller than the visible wavelength, 380 nano. See, visible wavelength range we have seen earlier. Human range is 380 nanometer to 830 nanometer. Okay, but generally we take as 400 to 700, because below that and above for 700 the color is more or less similar. So if the molecule size is smaller than the wavelength, which is 380 nanometer, the transparency will go up because there is a less light scattering. Extremely narrow absorption band, that's why the dyes appear much stronger in color, much brighter in color compared to the pigment. Okay, vehicle is not necessary because it's a liquid dye. Inferior light fastness, as I said earlier, the light fastness of the dyes is not so good. I mean, it's good for certain purposes, but pigment definitely has a higher life. Is oxidized due to bleaching. Dyes get oxidized. Okay, you must have seen in textile also. In textile, the clothes, when you wear the clothes after some time, the area which is exposed more to the light, it gets faded very soon. Okay, so these are dyes are fugitive. Okay, and then we can deposit on the paper. Now pigment colorant. So those were dyes colorant. Now we have pigment colorant, what we use in the printing ink, in offset and many other things. Okay, they are cross-linked molecules. Okay, cross-list. I think, is it coming? Yeah, okay, but then we can take some questions that time. That is okay. Let him get it. It's better that way. Okay. So the pigment particles, it can be 0.1 to 2 micron, and this has several molecules when it is that small. And in printing, or when the ink is manufacturing, these particles, they create agglomerations, you know, they come together. That's why if you go to the ink factory, you find that they have this triple roll mill through which the ink passes 2 times or 3 times, and it breaks down this agglomeration into smaller particles. But still these are particles, they are not dyes like completely soluble. Okay. Now when the light strikes the pigment, which may be deposited or which may be in the ink can, it's only 10% of the molecules on the surface that react. Okay, and maybe few below. So that is why, and so there will be a lot of light scattering, so therefore it has a wide absorption band as compared to the dyes, and it's not as pure as dyes. The intensity or the brightness is not as good as dyes. Pigment disperse light, as such they are opaque. See, these are particles, so when the light strikes, the light scatters, like light scatters in the paper because of the fibers. Same way the light scatters because of the particles. So the pigments has higher opacity than the dyes. Okay. It requires vehicle to deposit on the substrate, that's easy enough. Superior light fastness, which I already said. Okay. Less bleeding on the this point. Sometimes it's okay, sometimes I don't agree, because I know certain magenta inks, certain they bleed very easily. So it depends on the type of ink. Later on I'll show you another series, so you will be amazed that how many different types of pigments are there. Yeah, and the dyes. Okay, and the pigment, that is pigment portion that is in the ink, maybe 5 to 30% depending on the color, what color you want and so on. So now printing pigments. Okay, there are two kinds of pigments. I'm just giving you all this background because everything is going to affect your visual impression when you deposit ink on paper. Black ink or color ink, it makes no difference. So the printing pigment, there are two types of pigments, organic pigment and inorganic pigment. Okay, so organic pigment processing colors, most important in printing. Okay, two groups, chromatic pigments and black pigments. So chroma is color, so there are color pigments and black pigment. I got a whole list of pigments which I will show you later. Inorganic pigments, white titanium dioxide, okay, or white color, or metallic, gold, silver, bronze, pearlescent pigment, fluorescent pigments. Okay, so this inorganic pigment, they normally have a higher particle size compared to the organic pigments. That's why when if you are printing white very often, you find that your ink rollers, they get bad very soon. Yeah, they get damaged very soon compared to inorganic pigments. Resins dissolved in mineral oil. If you go to the ink factory, you find that pigments are dispersed in resin, and this resin is coming from natural trees, rosin, which they boil, and then it becomes resin, and that is mixed with the pigment. Okay, then you get your pastings. Pigments finely dispersed in the binder. Pigment particles enclosed by binder shell. So old days we used to get the ink. Now I am talking about the pasting. We used to get the ink where the binder was coated onto the few agglomerates of the pigment particles. Then at the same time there was something introduced called as the flush pigment, which every particle was coated with a binder, which gives you better ink strength. Okay, so nowadays many people are following that practice. So pigment particles enclosed by the binder shell. Shell protects finely dispersed particle from agglomerates, so your particle doesn't come again together, and they are nicely separated, so you can work your ink much better way. Binders dry or harden on the substrate to bind the pigment. Okay, so when that binder hardens, your pigment is bound to the substrate. Then additives. The type of additives depending on printing process. Okay, and it influences gloss, how your ink dries, what is the flow behavior. Yeah, you need different flow behavior for different printing processes. Okay, on the speed of the machine, on the how the ink is transferred, abrasion resistance, that is scuff resistance. Okay, so that all come from the additives. Carrier, that's good. Carrier substance for colorants in conventional printing process are thinning agents such as mineral oils, IPA, toluene, water, that is the solvents which are used in the inks. See, we have oil based inks, we have water based inks, we have UV inks. So these are all different inks which need different carrier. Ink transfer. So depending on the process, the ink transfer process changes. Ink splitting. In litho offset, UV flexo, letterpress, UV gravure, pad printing, the ink is transferred from one roller to another roller or to the substrate by splitting the ink. Ink is split into two and half the portion is transferred. Direct ink transfer in hot embossing or thermal transfer. Okay, there are thermal transfer where the ribbon gives impression. The direct ink transfer, ink through the opening, that is in screen printing, and spraying the ink, that is in inkjet. Okay, so these are the different principles of ink transfer. So in ink transfer, how the ink is transferred and whether it's a consistent transfer or not every time, that affects again ink deposition and ultimately color. Ink drying. There are different ways the ink dries depending on the process, depending on the machine you have and so on. So there is a physical drying, which is absorption of the ink, evaporation of the ink, evaporation of the solvent. Chemical drying, it's oxidation or radiation curing, infrared, UV, electron beam. There can be combination drying, different methods, like if you take say heat set offset printing, you have hot air flow and oxidation, okay, and certain amount of absorption. Solidification drying, that is ink fluid in hot state, solid after cooling, that is the solid inkjet solid system. Okay, as soon as deposited, it cools down and becomes solid. Ink anchors mechanically to substrate. It penetrates into the pores of the paper, in paper fibers, pressure between ink carrier and the substrate. Ink penetrates into the substrate by capillary action, that is inkjet. When the ink sprayed, or even the gravure printing on paper, okay, it's capillary action. In extremely smooth surfaces, ink held by polar interaction, chemical and physical effects between ink and the substrate. Okay, so these are all various processes. So you have to understand your process very well, what exactly happens, how your ink dries, to get ultimately consistent result. So now litho offset inks. These are highly viscous inks, and these are paste inks, like consistency like toothpaste. Yeah. Dynamic viscosity 4200 pascals. Ink is structured so drying components in ink do not harden over the rollers. So you don't want your ink to harden on the rollers. It must dry on the substrate or in inking unit or plate or blanket. For wet offset printing, certain portion of dampening solution via the contact with the plate and dampening unit. Okay, waterless offset, we have very few waterless offset machine, and there is there are only, I know only 2 or 3. Okay, waterless offsetting contains silicone oil to ensure non-printed areas do not get ink. If you look at the waterless offset plates, it has a silicone coating on the non-image area, so it doesn't take ink. so we don't need the damping solution there. The inks are special like this. Extremely thin ink films transferred onto the substrate. Okay. Newspaper, web, printing medium, viscosity, drying slowly, physically through absorption. So each process has its own speciality for ink drying, for ink transfer. So litho offset its ingredients now. Varnish, which is a binding agent, which is a hard resin, 20 to 50% with high proportion of olefin, alkyd resins, vegetable oils, linseed oil, soybean oil, and etc. etc. We don't have ink session, so we will not talk more about detail. But I'm just to understand color, which really depending on the inks you are using. I'm just giving you a background. Color pigment depends 10 to 30%, then additives up to 10%, dryers, waxes, agents, silicone oils, newsprint black, principal component, cheap carbon black. So sometimes some newspaper they use expensive 3-color inks and a cheap black ink because the black consumption is more. Requirements: high transparency for suitable mixing in overprinting. Inks superimpose on one another. Okay, so some transparency is required. Printability, brilliance, gloss. So your color, what you see, also a lot depends on the gloss, structure of the paper, structure of the ink, and any further operations like coating, lamination, and so on. Renewability, flow properties, drying, emulsification, water in ink, file behavior, ink acceptance by substrate, so on. Flexography inks. Flexography use liquid inks, yeah, liquid like water, okay. Except UV flexo, they are paste inks. So viscosity range 0.5 pascals, ink transferred to flexible printing plate. Now most flexo plates are highly flexible. Some people are still using rubber plates, but many are using now photopolymer plates, which are highly flexible, and the ink deposited on the plate is via Analox roll. Analox roll has minute depression which carries the ink and deposits onto the plate. Okay, and there are different inking system. There is a 2-roller system, 3-roller system, there is a chamber Dr. blade. So the ink that you use, for example, if you are using chamber Dr. blade, you have the ink which runs through the main tank and through the chamber. So there is a continuous ink flow, and some machines or many machines, when there is a continuous ink flow, you can control the temperature of the ink. You control the temperature, you are controlling viscosity of the ink. You are controlling viscosity of the ink, you are controlling color that you print. Okay, so, and so on. In the simple flexo system like 2-roller, 3-roller, it's not easy to control the viscosity. Solvent is evaporated after transport to the substrate through heat application. The heat dryers ink layer up to 1 micron. So this ink that you deposit in flexo, if your Analox roller gets choked up over a long run, it takes less amount of ink and you get color variation because the ink deposited on the substrate goes down. Flexography ingredients, pigments, or in some ink we also use dyes. Solvent type, critical role. Solvent used are ethyl acetate, alcohol. Water-based inks also need certain amount of alcohol. I mean small percentage of alcohol, otherwise it doesn't work properly. Also you need a longer drying system if you are using water-based inks. UV inks, that is paste inks for label printing. Ink requirements. Setting of ink viscosity very important for printing quality, because if you are using liquid inks, the viscosity will change continuously, especially in solvent based inks, and if there is no temperature control, then it's a disaster. No squeezing away of ink on edges of the raised image. Okay. Now with the The flexography, typical, we have been talking about the characteristic, you get a dark outline. Yeah. With new type of flexoplates, it's very difficult to make out whether it's a flexo or not. There is, because the plate edge, image edges are made in such a way it doesn't give dark outline. Okay, and there are some very good plates. Yeah, on Analox roller, that is going to give you a lot of color variation. Solvent evaporated after transfer to the substrate through heat application. Intermediate drying in color printing. So there are two systems in flexo and gravure. You have partial drying with the dryer on the individual unit, and then you have final dryer to completely dry your ink. Okay. Letterpress inks, viscosity goes very high to 150 pascals. On paper, paperboard dry physically through absorption, later chemically by oxidation. On non-absorbent transparent metallic papers, drying slowly through oxidation using oil-based inks. Something like heat set. 1 minute. Letterpress ink ingredients, okay. Similarly like offset, inorganic pigments, varnishes. Ink requirements, high transparency, because when inks overlap each other, we need to get the combination color, brilliance, gloss, printability, runnability, flow properties, drying, file behavior, abrasion resistance, ink acceptability, similar like other processes, but each ink has different ingredient. Gravure inks, shortest inking system. Yeah, you have the image carrying cylinder directly revolving in the ink trough. So shortest path. Use liquid ink and the fill image forming. It's like Analox roll in flexo. In gravure it's a similar thing, but you have the depth at different levels because you have to create the image, not for ink transfer. Okay. So here you have the similar problem about the, if ink dries in the cells, you will get variation. If your impression cylinder doesn't have the right shore hardness, it doesn't give the right impression. If your substrate trap is not right under the impression cylinder, then also you will not get the right transfer of ink from the cylinder. So gravure ink ingredients, simple composition, very low viscosity. So we have two parts here. In India, the publication gravure is done only by Hindustan Times now. They are weekly supplement. Okay, the rest are all packaging gravure. But in Europe, there are still many companies who do publications by gravure. So toluene, xylene, petroleum spirits basically for publication gravure, and ethanol, ethyl acetate, water, organic solvent for the packaging gravure. Because in packaging we have wide variety of substrate. Publication gravure there is only paper. Okay. Packaging gravure you have various substrates which needs different components in the ink. Okay, because it should not react with the product. It should be safe for children to handle. It should be safe for old people to handle. Okay, should not affect the food that you eat, and so on. The gravure inks requirements, range of ink is very large. Okay, coating thickness greater than 2 microns. Special metallic pigments we use many times. Even here, we have people who are printing the certain cosmetic boxes by offset. Thereafter, they deposit the metallic ink on the sheet fed gravure. And people like Parkson or other people, they have sheet fed gravure. Factors most important: selecting solvent. What is the boiling point? What is the evaporation rate? What is the flash point? Explosion limit? Odor? It's very important when it comes to packaging. Work safety and ecological compatibility. Then screen printing. Second, back to pastings. In screen we are using all pastings. Most varied substrate: paper, card, plastic, glass, metal, textile, everything you can print by screen printing. Very varied physical properties, chemical physical properties. So because the substrate range is very wide, you need very wide variety of inks. Okay. So 4 production areas: commercial printing with different advertising media, sales, screen printing, that is serigraphy, that is, I don't know if you heard of a novel studio, Marvel Studio. It's in Ahmedabad, and they produce one of the finest screen printing by serigraphy. It's a manual method. In fact, they have been getting the jury's award at the All India Printing Competition. Then industrial printing like bottles, tubes, cups, special processes, textile, circuit boards, car dashboard. Okay, that is from screen printing. Screen process ink requirements: viscosity matched to the ink layer thickness. Ink screen printing deposits very high amount of ink, up to 25 micron. So the mesh has to be suitable. Okay. So the thread diameter, the threads per inch, and so on, it's very important. Drying by evaporation of volatile solvent and paper, card, foil, everything. Or you can use UV inks. Most of the offset printer who print by offset, they send their jobs for UV coating to a company in bicolor. Yeah. So ink layer is very high. Electrography inks. Okay, we have what we call laser printer, or every printer people call Xerox. Xerox is a company. You have Canon, you have Ricoh, you have other people. So the important things there are: we have dry toner, we have liquid toner. As I said, in HP they have a liquid toner in HP Indigo. So the rheology is very important. Colorimetric, color values. What are the color values of the? How many have seen HP Indigo machine? Yeah, anybody else? In HP Indigo machine, sometimes people say that you don't get consistent color because it needs a very strict control when you print. So there are 2 controls which you need to. One is HP Indigo, they use the electro ink which are electrically charged. So they have a liquid with which you need to control the conductivity of the ink, and they have the second portion which you need to control the density of the ink. So if you don't control the conductivity and the density, you are bound to get variation. So most companies do not control this, but I know 1 or 2 companies who do a good job, because you need special conductivity meter or density meter to control this regularly. So you need to control this to get the right color values, colorimetric values. Particle size, the charging which comes from the conductivity liquid, compatibility with the subsystem, then safety. Okay. So if it's a toner, then you need to, many times now if you take the case of the office printer, laser printer, if you are using the refill toners, the particle size of the toner particle may not be exactly the same as what you get from the original company. And now as the resolution of any printing system is going up, you need finer and finer toner. So if you don't use the finer toner, you may not get the resolution you expect. Okay, so you will get smudge, it will again ultimately going to affect your visual impression. So these are electrographic inks which are in photocopier, laser printer and any toner based system. Inkjet inks. This is another digital printing system where we use the ink cartridges to deposit ink on the substrate. So you need to have right viscosity, right specific gravity, right surface tension, because the surface tension is very important for the ink to get easily transferred onto the substrate. Optical density, like we use the densitometer to measure ink deposit on the paper, same way optical density. Dielectric properties, okay, dielectric properties, there are certain inks which needs dielectrical properties, so it stuck to the paper the right way. Similarly, there are dielectric properties for the paper, pH, colorimetric values and safety. So reproduction problems. So all these factors, if they are not in the right proportion, not taken care, not tested at manufacturer's end and certain testing at your place, you get problem with the finish, you get problem with gloss, you get problem with dot gain, dot loss. Color strength may change, okay, if you don't check the incoming inks regularly. Whether it's a liquid ink, paste inks, doesn't matter. And you must check it on the substrate that you want to print. If you don't, because the substrate makes a big difference for the same inks. As the ink strength goes down, as the ink strength goes down, you deposit more ink to get the same density. So when you deposit more ink to get the same density, your dot gain increases, and then in some cases you may lose the shadow detail, okay. So dot gain, just we have seen this before, just a small explanation. Dot what you see on the film, or nowadays you can see what you read on the color monitor and what you actually print. The difference we say is a dot gain. So if your printing conditions are good, your dot gain will be even. If printing conditions are not good, your dot gain will be uneven. I got some samples here which you can see later on, okay. U error. U error is a color error. So when you get different batches of ink or from different companies, and if you see what is the color, and if it's shifting, that means you are not going to get the same result when the hue of the or color of the ink changes, okay. Every ink, every toner, liquid or powder or paste ink has U error and gray error, because as we said earlier in the previous lecture, that inks and dyes available all over the world, they are not perfect. That's why we need this big field, what we call color correction, because it has gray error and the U error. We discussed this last time. So same with magenta and same with cyan. So the gray error makes your ink look dirty, okay. So in your printing machine, if you change the color sequence and if you don't wash the machine properly, also you get this kind of problem. Ink sequence. If your ink sequence changes, your color, what you get of the combination changes. I got some samples here. Maybe we can spend some more time later on the. So we have variety of papers and variety of inks. Even if you take single black ink, it can have various different shades. So when somebody says I'm using CMYK ink, you have to know exactly what color values those CMYK has. Each ink supplier can have 10 different shades. Okay. So you must know what exactly the color values of those CMYK are, or the special color, because that decides what kind of tone reproduction we are going to get. Okay. Colors will shift if the gray error and hue error is different. Okay. So these are the basic slides on printing inks. Now, in printing, just don't think of CMYK, because now we are using a lot of other things. Okay, we are using metallic inks, we are using fluorescent inks, we are using pearlescent inks. Any questions so far on this? Yes, your question? I thought you raised your hand. So I will show you something on. I have this nice things from Merck. So Merck is in the business of special pigment supplier, what we call pearlescent pigment. I also have sample here. So there are special pigments they have developed. Effect pigments, iriodine, which are mica based. Yeah, I will give you more explanation on this. Color stream, xyralic, high luster effect pigments. So if you see some special packages or special products, they use this pigment there. Miraval, Biflare, Sirona, cosmetic pigments. They are also used in cosmetics. You know, when you see some lipsticks and all that which has lustrous appearance, these pigments are used there. Sorry? Yeah, you have not seen lipstick? You have to check with your girlfriend. You know, there are some lipsticks where you see the metallic particles. So, sorry, what was your question? In cosmetic packaging also you can use it, yeah. And also in actual products also you can use it. Yeah. Okay. So what is iriodine? It's a brand name from Merck for special type of pigment. Okay. It is giving you lustrous effect. 1 minute. Maybe I can pass around the. Here I have two samples. One which gives the metallic effect. It has underneath a luster pigment has been deposited and then printed, and one is without that. You can pass on maybe. So you see a nice effect. Okay. You have to see it together. It's not two separate. Can you see difference? Yeah, on that fuel tank. Yeah. So they have these different pigments, and they are highly magnified view. They look like this. very highly magnified. Okay, there's a metal oxide, and the interesting thing is when light strikes, the reflection is selective. Some waves are passed through, some waves are reflected, but it's not like the normal pigment. See how it works. If you deposit a thin layer, it will appear white. If you increase the deposition to some extent, the yellow is reflected and the blue is absorbed, so it looks yellowish. When you increase it, deposit further, red is reflected and the green is absorbed, so that it will look reddish. And if you increase still further, blue is reflected and yellow is absorbed. So at this level, yellow is reflected, but at this deposition, the yellow is absorbed. Okay, so the same pigment will look bluish, and here also similarly. Here green is absorbed, but when you increase the deposition, here the green is reflected. So it's a different kind of technology what they use. So it gives you this kind of different appearance. So it will give you different effect, gold, bronze, and so on. Yeah, bronze, copper, reddish brown, reddish violet. This kind of effects you will get. So it can be applied for various products, various packages. Also not easy to copy. Yeah, so some kind of security aspect. Packaging labels, gravure, flexo, screen printing, offset, UV, overprint varnishes, or it can also be put in paper manufacturing. Yeah, so it has very wide applications. In textile, okay, wallpaper, decorative paper, board. So it, as I said, it gives you security for pharmaceutical, perfumes, tobacco, textile, and everything. Okay. Then at some places it will also work as a color changing pigment. So when you look at it from different angle, the colors will look different. So it can be used in offset, can be flexo, gravure, screen, as I said, or it can be incorporated in the paper when the paper is manufactured. It can also be deposited at different level, on the top of the ink, on the top of the paper, within the ink, within paper manufacturing, okay, or final coating. So it gives you high gloss and everything what you can think of as a product security and to enhance as a value addition to your product. Okay, this we can skip. These are just showing different application. Okay. Then there is a short procedure in offset and okay. Flexo, gravure, screen printing using the photopolymer plates in flexo and letterpress. Okay. So this, then since I will also show you another one, which I think, I don't know, some of you may have been using it. Anybody uses Metal FX inks? Metal FX. Here it is slightly different compared to Mark. Here you have the transparents are used and there is one silver base inks. Okay, so you print on the top of that and you get various shades depending on the color combinations. You get various different metal effects. This is relatively simple compared to Merck, but Merck has many other parameters or the security aspect which you don't get here. Okay, now I want to show you. Let's look at the there is big talk going on in the industry, especially since last Drupa, because people need something more to talk about. They talk about hexachrome, 7 color printing and so on. Okay, so and they say no need to have many colors. So I did some study on that. I personally checked. Then I want to show you what are my findings. So we use in printing industry, we produce for variety of industries. So our print is expected to look like the product that is produced by your customer. Okay, so we use various substrates, various processes. I mean, different companies, same company may not be using all, but different companies use different substrates, different inks, different applications, different products. Okay, variety of processes to get that result. Okay, so we need to go for the approval, not just light, standard, dark. We need to measure it. Unfortunately, in industry, it goes as light, standard and dark. It doesn't give you good control, good idea. So we need to have some kind of control element, and we need to write there density or LAB values or what is the spectral color. So printing industry is like orchestra party. If it's a good orchestra and if any single person is not playing it right, the whole music is spoiled. Yeah? It's the same in the printing industry. Everybody has to do his job correctly to get the final result perfect. So we say color exists only in our eye. So then we also need consistent lighting, because the lighting affects the color that you see. So if you are using different color, different lights between your customer, yourself, supplier, and if there is no proper understanding, then the colors will look different. Because lighting level, there is a very wide variety of lighting. As the light becomes bluish, we say its color temperature goes up. Light becomes yellowish, its color temperature comes down. Okay. This we had discussed this earlier, so I will not go through it. Similarly, there is a intensity of light, how much light is falling on. So there is again wide variety of illumination or intensity, right from bright sun to full moon. You can see the range is very wide. So we need some consistent lighting, consistent viewing both. So we have various different colors in packaging application. We use CMYK, we use CMYK RGB, we use spot colors, we use special colors, pastel colors, metallic colors, pearlescent colors, and many others. So we have to do the color evaluation objectively and on a scientific basis. we must measure spectral values of the customer sample. Okay, just getting the Pantone number doesn't work, because each Pantone book you see may not look exactly the same. So you have to make sure the color is matched spectrally on the production substrate with the ink that you are going to use. Do not trust only LAB values, measure the whole spectrum and not Pantone number. So you also have to use the right formula when you say the color difference between the customer sample and your product is so and so. That's not enough, because there are 5 different formulas to specify delta E. If you don't use the same, then you are on different wavelength with your customer. Okay. So there has been 76, 94, CMC 1:1, CMC 2:1. Then the latest one is 2000. Okay. So you have to see which formula. Right. Here it is. In the printing industry, the colorants used, dyes and pigments by different companies, ink manufacturers, they are very wide. Okay. So these are the 4 types of dyes which are used in the printing industry. So you can see these are the basic color that comes: red, orange, yellow, green, blue, violet, brown, black. So your CMYK inks are also made from these kind of things. And these are the pigments. So there are 49 red pigments, 12 orange, 30 yellow, 4 green, blue. So if you put dyes and pigments all together, there are 66 different colorants of red. There are 20 orange, 50 yellow, 10 green, 36 blue, 21 violet, 16 brown, 10 black and 10 white. So inks are made from combination of these pigments or dyes. Therefore, your color matching is very important, because many CMYKs are also made out of this. There is no pure cyan pigment or no pure magenta pigment and so on. Okay, it's a combination. So when you use this, therefore you need to check the color of your ink, what you get, very religiously. Yeah, you must make sure you are getting the right, because when they process it at their factory, as I said earlier, when the temperature shifts, the color shifts. Okay. So there are many analog tools or digital tools. So we have to control color right from creation stage, design stage, pre-press stage, measure the color and then apply color management. That is systematic work, systematic standardization. So this I will skip, because we also have to see the samples. So what coming from the instrument, and when you measure it, don't think everything is perfect, because these instruments and many things which are designed, and the basic fundamentals are on certain assumptions. If you read the entire history or entire information about how they derive these parameters, it's also certain things are assumed which may work, may not work. Okay. So don't expect everything to be perfect, but whatever available we have to apply that. Okay. That's why it's a continuous evolving science, continuous development. So that was the first stage of vision, 1931. Then we have the second stage of vision, that you forget, because everything is ultimately here within our eyes. So eye structure is still not completely known. So therefore the color impression is also not completely known yet. Therefore the measure instruments are not absolutely perfect yet. There are a lot of limitations. Okay, so when you see the color, it's not just color measurement, just seeing which affect how your color looks. What is the gloss? What is the texture of paper, texture of ink? Okay, gloss, at what angle you are looking at it? What is the shape? Cosmetic box, if you look at from different angle, you will find sometimes the color changes. What is the surrounding? When you are printing, say big solid patch of blue on paper, and the same ink, if you print a very small dot surrounded by large white paper, the color looks different. Viewing angle, viewing distance, size, okay, shades, this I'll skip. So these are all the technologies involved in printing which affects your color. Okay, everything must be set right, whole thing must be standardized. Okay, various, I want to show you. Okay, we were talking about this. I took brand new Pantone books. I took solid Pantone book. I also took what is called Pantone Bridge, where they have a solid and they also have the 4 color combination which comes nearest to that color. Okay, and the Pantone Hexachrome. All 3 new books measure the color to see what is the difference between the same number, because everyone is benching, they benchmark at the Pantone that with 6 color, 7 color we cover 90% Pantone gamut, and so they covered 90%, but does it really match? So you can see I measured 55 different Pantone colors, and you find especially in the orange, blue and green, it goes to the delta E of 40 of solid color versus Pantone Hexachrome versus 4 color combination. Okay, so when they say we match 90%, to print 90%, but there is no match. That is why in packaging we still need to use special color. You cannot produce packaging jobs using 7 color. Okay, something like this, flat tints or this text, you have to use special colors. So you still need the ink kitchen, you need the ink management. In ink management, we mix the inks and we take a drawdown on the same substrate that we are going to print, and we measure that, and then we decide whether our ink is right or wrong. Now, if your job is going to be laminated, if it's going to be varnished, you have to take that into account. You have to put varnish on the top or laminate, and then your value has to come close to the customer sample. If you take without those after treatment, the final result may not come anywhere near what customer wants. So you need to have the ink management, ink kitchen, where, so some companies also have special system where the ink management is done also on the press. Then about the color profiles, your Gravier and Flexo is able to produce much larger profile, much larger color gamut than the litho offset. But still, most people say swap profile, this profile, that basically for offset. So if your system can produce larger gamut, why to apply offset profile? Create your own profile for Gravier, Flexo, and you keep your process under control. Okay? Yeah, that's the. Can we go through the sample? You can switch on the light. I have this white. Everybody has seen it. So this is various sheet feedings, scheme YK, and its gamut has been plotted. No, it's okay. This similarly for the heat set wave offset. Okay. Various different inks, different drawing system. This is for the cold set newspapers. Yeah. So each company has different gamut, different inks. These are plotted fluorescent colors. Now, when you measure the fluorescent colors, then you have to use certain filtration, and then you have to see. So this I have measured with 4 different filtration, and 4 different filtration, how the reading differs is indicated here. So you have to use the right filtration to get the right information. Oops. No, thank you. Here I have measured the metallic colors. When you measure the metallic colors, the normal densitometer does not work satisfactorily, because there are metal flakes, and the direction at which you measure, if you change the instrument direction, the reading will change. So there are special densitometers which are used for the metallic effect. So I have measured this with both, and I see how it shifts. Yeah. Here I have measured various colors, okay, from the camel color range, artist colors, and I have shown which colors fall outside which gamut. So there are gamut on sheet fade, newsprint, and so on, and these spots are for the artist colors. Okay, so which are going out, which are coming within the range. So in printing, what you can produce, you cannot produce. Then there are here I have a picture of Burj Khalifa. It's the same picture. One is with gloss lamination, one is with matte lamination, and one is without any lamination. So you can see how it makes a difference to the color. So the center one is printed one, the same one with a gloss lamination here and the matte lamination here. Okay. So we need to take this after process also into account when we look at the color management. Okay. Maybe you can, if you want to see it later on, you can, because they told me because of some function going on, they would like to finish. They don't want to wait too long. Here I have 2 different sequences. One is black, cyan, magenta, yellow, and the second is black, yellow, magenta, cyan. Yeah. So these are plotted and shown how the gray balance shifts, because the grays are most important when you do color reproduction. So let me show you. So these are plotted on the LAB diagram. So KCMY and YMC, how it shifts, in which direction it shifts. If you want, you can see it later closely. Here they have calculated delta E, and here I have calculated two color combination. How your ink trap changes in red, green and blue. Okay. So one against the other. Yeah. Where you get better reproduction of red, green, blues compared to the other sequence. So there is a comparison of two sequences. Okay. There are this is a study on various different substrates by Gravier, some by Flexo, on aluminum foil, on matte PET, on lenticular foil, on paper. So how the color differs when you print the same thing on different substrates. I don't have another table, so I'll just put it back here. Here I have samples of two Flexos with a change in analogs roll. So with one analogs you are getting better gradation, with smoother vignettes as compared to the other. So that gives you better color, smoother gradation. Maybe we can also discuss it later. Then I have paper with two different sequences. In one sequence the cyan, magenta, yellow sequence, second one yellow, magenta, cyan. So how the perspective of the image changes when you change the sequence. So you can see this one looks flatter than here. Same newspaper. We just change the sequence and print it again. Yeah. See, everything same. So in one you get a better perspective, better depth, better three-dimensional effect compared to the other one. You have to see this little bit minutely with closer. Same ink, two different fountain solution. So with one fountain solution we have better brightness of colors compared to the other one. Yeah, two fountain solutions from the same supplier. Oops. What else? Once you decide your gray balance, the gray balance is the most important in color reproduction. When you decide the gray balance, the same gray balance does not work for all the screen ruling. If your screen ruling goes coarser, it becomes pinkish. If it becomes finer, it becomes greenish. So there is a narrow range for the gray balance, which also you can see from this printed sample here. When the screens have gone very fine, this t-shirt has become greener. Yeah, the same gray balance. So these are the various aspects of color reproduction, or you can say color management. Then what else I have? This is a pearlescent paper which was done on HP Indigo. So here the pearlescent effect is in the paper itself. Yeah. So shall we discuss these samples more? Then we need little bit, I think. So you need to see the sample, yeah. So table khalti and tile. Because I thought you might want to discuss samples more, yeah. So we can have a better discussion.
Better. Light is inside.
This may be download from the TCSI. The control conditions. Yeah, otherwise everything affects, like I said, everything affects the
First thing we want, last time we had just do the project in there, we had put the some few colors and some taste arts on it. Okay. So, but we cannot got the proper gamut.
but to work as a basic, okay. For basic work, you have to start somewhere, so it's okay. But how you measure, that is important. How you measure, that is important. I also do that way sometimes. What values you measure, what density you measure. Visually. Sorry? Editing you cannot find out.
And matte.
Yeah, you can only find out which is block.